This video will cover what stable detection means and how to achieve it with Keyence clamp-on ultrasonic liquid flow meters. First, let's define stable detection in reference to our flow meters. Stable detection is a state in which the flow meter is consistently and reliably receiving strong ultrasonic signals. This can be easily identified on our flow meters with what we call stability bars. Each of our flow meters has 4 stability bars, and with 1 bar blinking, that indicates no stability, and with 4 solid green bars illuminated, that indicates full stability. Stability bars are analogous to cell service bars on your cell phone. If you have no cell service, it will be very difficult to make a phone call. Similarly, if the flow meter has no stability, it cannot stably detect the flow and may show inaccurate and unrepeatable values. Now that we understand what stable detection is and how to identify it with our stability bars, let's understand the principle that leads to stable detection. Laminar flow is a type of liquid flow that is smooth and consistent, leading to the ultrasonic signals being able to be emitted and received by the flow meter. Having laminar flow directly correlates to having high stability. On the contrary, if the liquid is turbulently traveling through the pipe, the ultrasonic waves will be affected by the chaotic movement of the liquid and may not be received by the flow meter, leading to low stability. Let's use this piping setup as an example and identify good and bad spots to mount our flow meters. Since these are clamp-on flow meters, we can't control whether there is laminar or turbulent flow within the pipe, but we can strategically pick a mounting location with laminar flow. Starting at the top left, there are 2 pipes joining together into 1 pipe at a T-joint. The flow becomes turbulent going into the T-joint and extremely turbulent as it exits the joint. The pipe then does an aggressive bend, which we also want to avoid. Next, there is a valve which can cause turbulence as it can disrupt laminar flow. Afterwards, the flow goes to a vertical straight pipe going downwards, which we also want to avoid because air pockets can form here. We finally get to a long horizontal straight section which laminar flow can form. This would be a great place to mount a flow meter. As the pipe turns, avoid mounting next to all bends. Now there's a long vertical section with flow going upwards. This is another great mounting location as gravity helps reduce turbulence and create laminar flow. And once again, avoid mounting near bends in the pipe. As a recap, long straight pipe runs are ideal mounting locations, especially horizontal pipes or vertical pipes with flow going upwards. Now that we understand what stability is and how to achieve it, utilize the stability bars on the flow meter to confirm that the flow meter is mounted in a good spot and detecting properly.